Now, what are the most common faults gas engineers find when they're out there servicing and repairing combi boilers? Well, in this video, that's exactly what we're gonna find out. Is it that the installer has made a few mistakes? Or is it the installer is actually not qualified to actually install boilers and is making these mistakes because they don't know what they're doing? So let's get on with it and let's find out exactly what the common mistakes are we do find on combi boilers, and we'll see whether we think it is done by gas engineers or whether it's been done by non-registered installers. Now let's have a look at the flue system first, because we'll start at the top of the boiler and we'll work down to find these faults that most gas engineers find when we're out there servicing and repairing boilers. Flue system, a couple of things with them. First of all, the flue needs to be sealed to the wall on the inside. It also requires to be sealed on the outside unless the manufacturer says the collar what they supply is a good enough seal for the weather and the products of combustion. But I don't think any manufacturer's seal would be able to seal the size of this hole. Is this just laziness, or is this non-registered engineers installing this? Surely a gas engineer wouldn't leave it like this, because it's not sealed inside or outside, so the products of combustion can come right back into the house. Now, can your flue do this? Well, if your flue could just pull out like that, then it's not been installed correctly. Now, the manufacturers of this flue, which is Ariston, do not screw this clip here into the turret. It's all done with sand and cement in here. So you have to sand and cement there to stop this being able to pull out. Now, this is also a regular fault we see when we're servicing boilers, that somebody has tried to seal the flue up using expanding foam. This is not the way to do it. Now, a lot of boiler manufacturers have screws to hold their flues in, and we find a lot of these screws are missing. Now, this is a glowworm boiler, and you can see this collar here. It should be screwed in these two holes, which the manufacturer supplies. When we're servicing them, if we find the screws missing, we must at risk this appliance, because the manufacturer says this flue system requires the screws to stop it pulling out. Because obviously if your flue comes out, you've got products of combustion then coming into the room, and that will become an ID or an immediately dangerous installation. The other thing we also find with flues is them sticking out of the wall too far. Now, I've seen flues like the one you see now, where the flue is virtually the full length of the flue just sticking out the wall and it hasn't been cut down. Now, that would send massive alarm bells for me when I go to service a boiler and I find a flue sticking out that far because it hasn't been cut down. And I would say 99 times out of 100, that flue has not been cut down because a non-registered engineer or a non-qualified engineer has installed that boiler. So it could be the homeowner, or they could have got a family friend in to do it. So flue sticking out the wall, massive alarm bells ringing. Also, flues being too close to openings into the building. That's another massive sign that the flue hasn't been installed by a gas registered engineer, because we all know the dimensions of how far we need to be away from openings in buildings, and there will be no, or there should be no gas engineer out there who's stupid enough to install a boiler and not install the flue locations correctly. So a flue from the side of the flue to the opening of a window needs to be more than 300 millimeters away. Other problems we see is carports. Now, a lot of the time when we go to service boilers, the carport's been built after the boiler's been installed, and a lot of the time you can see this because they've made big holes in the carport where the flue goes out. Builders can cause us quite a few problems with fluing locations when they're building extensions. So if you are having an extension built, make sure your boiler gets moved first before the builder starts doing the job, so you don't end up with your flue systems being altered like this, or terminating inside the extension, so products of combustion coming into the extension will make it immediately dangerous and could kill you. Now another problem is damaged flues or corroded flues. So you can see this one is badly corroded, but a lot of the time we see the terminal being missing here. And again, if this terminal is missing, then the flue is damaged and the flue could be at risk. This doesn't automatically show that this flue hasn't been installed by a gas safe registered engineer. But if you've got your flue sticking out the wall a mile and it's corroded, then yes, because seals can fail. So if you do see orange on your flue system, then you need to get an engineer out as quick as possible, because it could be corroded on the inside. And a lot of this time when flues get this bad is because they've not had the boiler serviced. So when you have your boiler serviced, your engineer will be checking the flue, and it's a test called the flue integrity test. So the engineer will be testing the integrity of this flue and make sure that the seals haven't gone and the condense isn't rotting away the steel outer of the flue. It is becoming a very common problem, and it's mainly because customers don't have the boiler serviced, or they don't have the boiler serviced by a registered engineer. Now this picture shows a prime example of not having a boiler serviced, because you can't tell me this has happened to a flue over the last 12 months. It would take a lot longer than 12 months to make this much of a mess. So as you can see from this video, already one of the major problems we have as gas engineers when we're coming out to service boilers is the flue system. But really, it shouldn't be a problem. Every boiler manufacturer's instructions produces a chart like this one that shows you exactly where the flue can be installed. So technically, no flue on a boiler should be installed incorrectly nowadays, because we just need to follow the manufacturer's instructions. Now GasSafe have produced a technical bulletin 152 on the sealing and securing of horizontal flues, and it's free to download. Now another thing with the manufacturer's instructions that sends my gas engineer's senses tingling is when the benchmark book hasn't been filled in, because you don't leave any proof you've been there, you can't get blamed for it, can you? That automatically for me is, if this hasn't been completed, that it's a non-registered engineer who has installed that boiler. Also in the manufacturer's instructions, there's a section where the engineer fills in for servicing as well. And if this hasn't been filled in, then again, I would be thinking, this hasn't been serviced either. Now a lot of customers, when you go around to their house and you ask for the manufacturer's instructions, they haven't got a clue where they are. But really, why aren't engineers saying to the customer, I need your instructions so I can fill in your service stuff at the back of your book, and to check that it's been installed correctly and what the readings were when the boiler was initially installed. So the manufacturer's instructions can tell us a lot whether we think it's been installed by a gas engineer or it's not. Other common faults we find when we're going out to these boilers is electrical wiring faults and lack of controls. Now, a couple of the things for the wiring. Now this boiler is wired via a plug, and the plug is into a switch socket. Now the best way is into a fuse spur with a 3 amp fuse. But if it does go into a plug socket, which technically it can't have a switch on there. It's got to be an unswitched socket. And a lot of the time when we're doing services and we're opening up the plug tops to check the fuses, or checking the fuses in the fuse spurs, they've got a 13 amp fuse in there instead of a 3 amp. So if you don't have the right size fuse in your boiler, you could actually, if there was some kind of surging or problem, it could blow the board on the boiler rather than blowing the fuse in the plug or the fuse spur. So, very common problem, incorrect fuses, incorrect sockets, and controls. Now all boilers now have to comply with Boiler Plus. So that means it's the Boiler Plus controls. And we can't just have a standard time clock now with a standard room stat. We have to have stats which are able to know what the temperature is in the room and what temperature you've set it to. Now a lot of guys who installing boilers will be sticking to one specific type of controls. I prefer the controls made by the manufacturer because it always makes the boiler run at its best. But we do go to a lot of boilers where there's no controls whatsoever, or there's just a time clock like there is on this boiler here, and the customer just turns it on and off when they want. They don't have a room start, which is costing a lot of money on wastage of fuel and energy, which in this day and age is not a good thing. Now make sure it's always got the right size fuse, it's wired correctly, and you have controls to Boiler Plus. So when you're getting a new boiler installed, make sure your engineer is fitting controls that comply with Boiler Plus. And if you've got no controls, I'd be getting some if I was you. It might save you a few quid. Invest to save. Now we've looked at the flue, we've looked at the controls. Let's have a look at the common faults that we find underneath the boiler on the pipework. Now looking at the pipework underneath this boiler, the first thing we can see here is there isn't a magnetic filter. So according to BS 7593 2019 and Part L of the building regs, what quotes the British standards, it says every boiler installed requires a magnetic filter. But your boiler might have been installed 10, 15, 20 years ago and it wouldn't have a filter. But a newly installed boiler, under warranty, ready for servicing, would require a magnetic filter. And what this filter does is it gets rid of any magnetite out of the system. And magnetite is created by corrosion. Now this is what the magnetite does inside the pipe and the fittings. It also reduces the flow going to your radiators. So before we install a new boiler onto an old system, we must check the water quality. We use a turbidity tube to do this. So you can see here the water quality is rubbish because we should be able to see the bottom of the tube. Now you can see here the turbidity tube on the left has central heating system water that wasn't protected, and the turbidity tube on the right has central heating system water that was protected. So to stop the system corroding, we have inhibitors in the system. And that's another fault we find because also BS 7593 2019 says we require the system when we're servicing it to be checked for its inhibitor and its cleanliness. So we can see straight away, looks like there's about 20 parts per million of inhibitor. So according to these Fernox Express inhibitor test strips, I'm going to need to put some inhibitor in this heating system. And that's another fault we find. Brand new boilers being installed on dirty, corroding systems. So from the very start, this boiler is losing its efficiency because it's on a dirty central heating system. Because a dirty system will need more energy to heat that water, to get it to the radiators, and then to get it out into the rooms. So the filter is incredibly important, but also a clean system and a system with inhibitor is also very important. Also underneath the boilers, a lot of faults we see on the pipework is it's either messy and horrible, or the gas pipe is undersized, or the flow and return are undersized. Now technically messy pipework underneath doesn't really affect the boiler, only it looks horrible. But undersized pipework makes a massive difference, whether it's the flow and return pipes coming off the boiler or whether it's the gas supply coming into the boiler. So you can see the gas supply coming here into this boiler is 15 millimeters. Now the minimum size going to a combi boiler has to be 22 millimeters up to where the manufacturer makes its connection. So the gas pipe will need to be sized depending on how many kilowatts there are on the system, how long the gas pipe run is, what size the gas pipe is, how many elbows there are. So it's a big calculation to work out the size of the pipe. So we see a hell of a lot of installations where the gas pipe is massively undersized, and this can affect the safe operation of the boiler or other gas appliances, so it can make an immediately dangerous situation. Now, probably the most common faults I see on boilers underneath them on the pipework is the termination and the installation of this pipe, which is the safety discharge pipe or the blow-off pipe, and the condensate pipe. Now, the first thing, you don't want to be seeing this plastic push-fit fitting over the end of the pipe, or any cap end on the end of the pipe. Now, this is one of the most common ways of terminating a discharge pipe, where they use an elbow to turn it back to the wall. But most of the time it's installed incorrectly because there isn't enough gap between the fitting and the wall. Even this one doesn't have enough distance between the fitting and the wall. It must be at least the diameter of the pipe away from the wall. Now, this is the way I prefer to do the discharge pipe, where the pipe runs down the wall and the full diameter of the pipe isn't restricted. There are also a few manufacturers who make a special termination point, which looks very neat and allows all the water discharge safely. Now, some installations you may see the discharge point and the condensate pipe run into the same pipe. This is not the way you do it. Now, this is the way I prefer to do it. So the condensate and the discharge go into the same drainage system, but you'll require one of these, which is a ton dish, which is an air brake, and a non-return valve. We've also got this dry trap ton dish, which is called a hotton, which is kind of the same thing. So when we turn it around, you can see the cutaway. So the water would discharge down there from the boiler. The water would open this seat and discharge to drain. And then when the water's finished, it closes back up, and that stops any smells from drainage coming back up into there. So it's another great product to use. So we've got no excuses for not doing the job correct. So that's the hotton. Now, this is also a common termination of the discharge and the blow-off, but it's actually wrong. So these are terminating on the roof, and you can see the condensate is going on the lead. Now, the condensate coming off the boiler is acidic, so it will corrode the lead. And also you can see the blow-off is pointing down the roof, and that, if it did blow off, could cause somebody some harm with the boiling hot water. Now, this isn't as common now as it used to be when condensing boilers first came out, where you see the condensing pipe, which should be made of plastic, has had copper used. Now, like I've said, it is corrosive and it will actually rot straight through the copper. Now, again, I've seen this quite a lot of times where the condensate has been terminated into a flower box, where whoever installed the boiler has actually said to the customer, "It'll water your plants for you." Really? And again, if I saw this on an installation, it would be screaming non-registered to me, because I don't think any gas engineer in the right mind would run a condensate like this. And again, this one screams non-registered as well, because really all they've done is terminate it over the footpath. So you can see, it just goes on the footpath. So if you do have your condensing pipe running down your wall like this in just overflow pipe, it used to be done that way, but it now does not meet the regulations. So the boiler manufacturers and the regulations now state that the condensing pipe needs to be insulated if it is run outside, whether it goes to a soakaway or whether it goes to a grid. Now, I've found the best product to use for insulating this condensate is called Condensate Pro. It complies with all the regulations, it's waterproof, and you don't have to paint it every year. Now, all this information about the installation of boiler condensate pipes can be found in GasSafe's Technical Bulletin 155. Now, this technical bulletin is just actually the HHIC, or the Heating and Hot Waters Industry Council, installer's guide for condensing discharge pipe installation. It's free to download, and all you've got to do is search for GasSafe Technical Bulletin 155 and you can get it for free. Now, this next fault we're going to look at is probably massively overlooked by gas engineers, and that is the installation of the filling loop. Now, the boiler we've got here has a built-in filling loop, and that complies to all the regulations, including the water regs. Now, a lot of boilers have an external filling loop, and it possibly could look like this one. Now, the way they used to, or the way we used to install them, was the double check valve went on the return side of the heating, and this isolation valve, service valve, whatever you want to call it, was on the cold water, and they used to sit in the boiler like that, in the pipework. So, like that. Then a few years ago, we changed it. So what they did was, the return pipe had just an isolation valve on it, and then the double check valve, which is this here, isolation and double check valve, goes on the cold water, because the double check valve is to protect the cold water, so our fluid category 1 from the fluid category 3 central heating water. So this link must be removed when you've finished filling the system up, so there's no back siphonage of the central heating water into the category 1 drinking water. So a lot of the time this is massively overlooked by engineers, and they don't really look at this because it's covered by the water regs, not gas regs. Have a look at your boiler at home. If it's a Combi boiler and it's using a filling loop, have a look if that filling loop is actually installed correctly. Now, a lot of the internal filling loops, they fill up on the flow pipe, not the return. So it doesn't really matter which way round they go now. But the double check valve is there to protect the drinking water, not the central heating water. A common fault which I think we're going to be finding in the future is the pipes underneath the boiler not insulated. Now, when the building regs changed, or Part L of the building regs changed on the 15th of June 2022, so last year, it said when you're replacing a boiler, you should insulate all the pipework that's exposed from the boiler or at a cylinder. And that doesn't mean that your pipes coming up to your radiators need to be insulated, or your pipework underneath your floors, if they're in the envelope of the building, don't need to be insulated. But it's slightly different if it's a complete brand new system. So that's the common faults we find underneath the boiler. Now, like the lagging, I think this is going to be another fault we're going to see quite a lot in the future, and that is carbon monoxide alarms. Now, the regulations have changed that all rented properties in England now require carbon monoxide alarms to be installed. But also, if a brand new boiler is installed in anybody's house, we also should be supplying carbon monoxide alarms to protect the customers from CO poisoning. Now, am I being a bit naive here? Am I thinking that all these faults, what we find on a regular basis, have been done by non-registered engineers? Or are they just lazy engineers? Well, the amount of checking that an engineer goes through, I would like to think that there are no gas engineers out there installing boilers absolutely wrong or not to the regulations. Now, do you think any different? So if you're an engineer and you're out there seeing these faults, what I see on a regular basis, do you think they are done by non-registered engineers, or do you think lazy engineers? Or are you going to do the usual thing on blame it on fast track gas training engineers? So, put it in the comments and let me know exactly what you think. My thinking is, most of the time what we see, it cannot be gas engineers. It can't be, whether they're new engineers into the industry or whether they're engineers who've been in the industry for 30 years. Certainly things like fluing locations, I can't think of any gas engineer who's going to purposely install a flue in the wrong location. So, hopefully you found this video interesting, hopefully you've got something from it, and I'll catch you on the next one, guys. Cheers.